Hey, homework problems from 7.2, estimating a population mean. In this problem, we're going to construct a confidence interval, but we're going to use a t-score instead of a z-score. So the first thing that I like to do is go through my question and then write out my formula, and that helps me to identify everything, get everything organized and structured first. So 45 subjects were treated with a new drug to lower cholesterol. Cholesterol levels were measured before and after the treatment. Changes in LDL levels have a mean of 2.9 and a standard deviation of 17.5 milligrams per deciliter. Construct a 90% confidence interval in the mean net change of LDL. Subjects were selected randomly. Alright, so as long as our sample space is greater than 30 and it's random, then we are good to go with our test. So first thing I'm going to do is I'm going to write out my formula, and again we're using t-score for this. And then my information that I have, so n was 45, my mean 2.9, standard deviation, and it was a 90% confidence level. So I have S and I have N, so I need to calculate this. So the first thing I need to find is A. So A equals 1 minus the confidence level, or alpha, sorry, instead of saying A. 1 minus 0.9, so alpha equals 0.1. And I'll write it over here. So alpha divided by 2 is equivalent to 0.05. So what I want to show you is that I can look up both of these scores. On my table. Oh, another thing. Sorry, I needed one other thing. My degrees of freedom. It's based off of my sample space. And that was n equals 45. So, we'll look at the first one, 0.1. That is the area in two tails. That's both tails put together. Remember, we're worried about the right one, but with our t-scores, the way our table's set up, we can just look up the area in both tails at once. We don't have to do the division. 0.1, and I go down to my degrees of freedom, 45, and 1.679. 1.679. But one thing to do in math is, if you're just comfortable with always dividing alpha by 2, then go ahead and do it. You can look that up. So 0.05. Area in one tail, 0.05. And see, each one of these values up here, area in one tail, is half of the score of the area underneath it. So same column, still the same number degrees of freedom, 1.679. You'll get the same score, so you can look it up either way. Also, with your degrees of freedom, these are listed numerically until you hit 50, and then they go by tens. For your homework problems, round to the closest one, round to the closest degree of freedom. Alright, now let's plug into our formula. E equals 1.679 times 17.5 divided by the square root of 45. Calculator. 1.679 times 17.5 divided by the square root of 45. and I'll round it to 2 places. 4.38. It's my margin of error. So 4.38. And then I set up my confidence interval. I have x bar minus the margin of error and the mean plus the margin of error. Population, sample mean population. Let's calculate. Get a negative 1.48 mu .28, and then within your problem we should include the units, so that would be milligrams per deciliter. But really it's about getting the answer, knowing what we're doing. So again, series of steps. What I would say is to have the formula memorized. Write all of your information out here. All of this, I don't even like seeing it. I just like having my numbers in front of me, and then it simplifies everything. This looks really busy, so much words and so long to actually ask what you're supposed to do. So once I get it down here and I have all my information encapsulated and I know my formula, this simplifies things for me visually and mentally. It helps me say, okay, I simply need to find this. Out of all this stuff, this is the first thing I need to find. I calculate it. Again, with your t-scores, separate table. Sorry, I should have said that too. Use table A3. Table A3 for t-scores. Separate table, and your sample space, your sample size, will be your degrees of freedom. You can do 1 tail or 2 tails. I'll write that down there. This is 1 tail. This is 2 tail. You'll get the same answer. Again, it's whichever one you choose. Okay? Whichever way you can see it. And then once you hit that, you solve for t sub alpha divided by 2. Plug it into the margin of error formula and calculate. After you do that, plug it into the confidence interval formula, and then find your confidence interval. Okay guys, watch your publisher's videos, critically think and structure your homework, and good luck on your homework.